Welcome again, ladies and gents, to another flipped lesson. Today our focus is going to be on understanding what we mean by the term electrolytic cell. So we spent a lot of time the past week talking about voltaic cells, and these are spontaneous redox reactions that make an electric current. So we've learned that we put our more active metal on the anode because it's going to oxidize and lose electrons. Those electrons are going to travel through a wire to our cathode, where ions in solution are going to accept them to turn into metal at that cathode. This is a spontaneous flow of electrons from anode to cathode because our more active metal will lose to the less active metals ions in solutions. As the electrons travel through the wire, they're going to be moving at a rate that creates a voltage, and that voltage is going to tell us the flow and number of electrons that are moving from anode to cathode. And so we learned in our lab that the further apart the anode and cathode are in the activity series, the more this wants to lose, the more this wants to gain, so we'll get a lot more electrons moving through that wire to go ahead and create a higher voltage. But when will this battery stop making voltage? One of two things has to occur for that to happen. If we think about what happens at the anode, this solid tin is turning into ions in solution. So if at some point we use all of this metal up and we have no more solid metal to turn into ions, we have no way for this metal to lose electrons anymore. So we would not be able to produce any electrons, which means we would stop making voltage. The other way our battery can die is if we run out of ions in solution to reduce. In order for us to complete our circuit, the electrons that come to the cathode have to be accepted by ions in solution to turn into that solid piece of metal. So if we run out of copper ions to accept the electrons, we have no way to keep the electrons moving through the wire. So therefore, we will no longer get any voltage as well. So those are the two ways that can cause our battery to die. Now we know that some batteries are rechargeable. If we think about your cell phones, all you have to do is take your cell phone, put it to your charger, and plug it in the wall overnight. So sometimes we can actually recharge a battery to allow it to produce volts again. So how do we do that? If we think about just a voltaic cell, this is a spontaneous process where our anode turns into ions and our cathode turns into solid metal. So our half reactions would be our tin turning into tin ions, losing electrons, our copper ions turning into solid copper, gaining electrons. So our overall reaction is solid tin turning into ions and copper ions turning into solid copper. It's spontaneous and it creates volts. So if we think about how to recharge it, what we would want to do is we would want to make both of these reactions go backwards. So when you charge your cell phones overnight, what you're doing is you're providing an external energy source that is allowing the redox reaction to occur in the reverse direction. So for us to recharge this battery, what we would have to do is we would have to hook it up to some external power source that was greater than 0.48 volts, because that would allow us to make the electrons go in the reverse direction. So our copper metal would become our anode, and our tin metal would become our cathode. So our copper metal that we built up while we used our cell phone during the day would be broken down. The copper solid would lose electrons, turning back into ions, building them back up in solution. The electrons would move through the wire to the tin, which would pull the ions out of the solution and recreate our metal. So we'd be, in effect, building up all the pieces that we just broke down over the course of the day. So if we look at the half reactions, our oxidation is our copper turning into copper ions, which are going to get those back in our solution. Our reduction half reaction is the tin ions turning back into solid tin, which is going to make our anode back. So our overall reaction is the reverse of our voltaic cell. So when we think about voltaic and electrolytic cells, they all fall under this main category of electrochemistry, which we know is the study of the interchange between chemical and electrical energy. So in a voltaic cell, we use chemicals to make an electric current. In an electrolytic cell, we use electricity to make chemical changes happen that are not spontaneous. So our electric current is making the chemical change occur. So if you look a little bit closer at an electrolytic cell compared to a voltaic cell, we're going to see a couple of differences right off the bat. First and foremost, we can see that we only have one container in this electrolytic cell. So voltaic cells have two, where our electrolytic cell only has one. Another big difference that you're going to see is when you're defining your anode versus your cathode. Your anode is going to be the metal. Oops, sorry. Your anode, okay. Sorry guys. I gotta get my pen here. Our anode is going to be the guy that is going to be the less active metal on the activity series. And our cathode is going to be the guy that's going to be the more active metal on this activity series. Because this is an electrolytic cell that is non-spontaneous, we're making a chemical change occur that does not want to naturally happen. So we're going to make our less active metals oxidize and our more active metals reduce. How we do that is by hooking everything up to a battery. We talked about how batteries have positive and negative sides, not sizes, and that's important for our electrolytic cell function. Whatever metal you hook up to the positive side of the battery is going to lose electrons. This positive side of the battery is going to act like a big positive magnet that's going to attract all the electrons from this piece of metal. So this piece of metal is going to oxidize, making ions in the solution as the electrons leave to go into the battery. So this time, this electrode is going to take on a positive charge because it's hooked up to the positive side of the battery. Our cathode is going to be hooked up to the negative side of the battery, and what this is going to do is it's going to pump electrons out. It's going to be our electron producer. And because of that, that's going to cause our electrode to take on a negative charge. So our anode is going to be our less active metal, and it's going to be hooked up to the positive side of the battery to make the electrons lost by this metal, because it doesn't want to naturally happen. Our cathode is going to be hooked up to the negative side of the battery, gaining electrons, because normally it would not want to gain electrons. So this helps us make a non-spontaneous process happen. It helps us reverse a normal oxidation reduction reaction. You'll notice we don't have a salt bridge because we only have one solution. And so that's another big difference between electrolytic and voltaic cells. So what I'd like you guys to do for homework is complete the Google form and also make a little compare and contrast chart about voltaic and electrolytic cells. And this is going to be where we start class tomorrow. Have a great night, guys.